Hi guys, welcome to another one of Dowlath revision series, and we're up to video number 20. Today's lecture deals a little bit with Archimedes' principle and looking more so at the challenging application of it. So if you recall from the last video, number 19, we saw what Archimedes' principle was, which was a formula for the magnitude of the upthrust of a force. So as an object is immersed in a fluid, the molecules in the fluid will exert a resultant upward force on it. And that occurs because you have a pressure difference on either surface of the body. And it is that pressure difference that gives rise to a resultant force that is directed upwards, called the upthrust. So when we want to determine the upthrust, we can also link that to density, namely because the formula for upthrust is rho Vg. So let us consider one of the more challenging applications which actually can be used as well at the cape level. Okay, so let us consider an object having a weight in air of 10 newtons. So if the object has a weight in air of 10, then weight is mg. So you can determine the mass of the body, which is the weight over g, which is 10. Let's consider g as 10. So we get the mass as 1 kilogram. Now, if you take this object and you submerge it into a fluid of density rho, then we saw previously that the fluid would exert, the molecules of the fluid would exert an upward force on the body. Remember, this is a resultant force, right? So when we do an experiment, one of the more popular ones is that you immerse a body in a liquid and then you can attach it here to a spring balance, right? And you're going to get a smaller value for the weight of the body when it is immersed in a fluid, and that is what we call the apparent weight. Now that apparent weight is a resultant of multiple forces acting, namely the weight as well as the upthrust. So naturally, if you do a free body diagram, what you will notice is that you'll have the upthrust, you'll have the weight like this. So the resultant of these two is what gives you this apparent reading on your spring balance, which is the apparent weight. So the difference between, let's say the value worked out to be 8 newtons, right? So when you immerse the body, your spring balance, which is a device to give you the weight or the force acting on a body, gives you 8 newtons. So it is in fact the difference between the two, the 10 and the 8, that gives you the upthrust. So once I determine the upthrust is rho Vg. It is the volume of the object that is immersed in the fluid. You have the density of the fluid. Let's just say, for example, it's water. So its density value is 1,000 kilograms per meter cube. Then you can work out what V is. So V works out to be around 2 by 10 to the minus 5 meter cube. So then I can get the density of the substance. So whilst I'm using my weight in air as 10 newtons, I could deduce from that the mass of my body is 1 kilogram. Having the volume calculated from the calculation of Archimedes' principle, I can work it out to give me 2 by 10 to the minus 5. So dividing those two, I can get the density of the body being 50,000. So this is just one of the more challenging ways that the principle can be applied.